All right, here we have a story about a train. Let's make sure there's nothing I'm missing here. Okay, yeah, looks like I gotta answer the phone. All right. Anyways, so we got this crazy bullet train that goes at 140 miles per hour, and we're trying to figure out fill out this table. It's partially filled out. We've got some times, we have some distances. So we're trying to figure out, where does it travel in half an hour? How long does it take to go 105 miles, or et cetera, et cetera. So, anyways, so let's see. Well, first of all, some of these are going to be pretty easy. Like if the time is 0, then your distance is also 0. That's pretty easy. Then let's see if time is 1. That's easy. That's 140 miles. That's what 140 miles per hour means. One time, 1 hour, 140 miles. If it's 2, that's going to be 2 hours at 140 miles an hour is 2 times 140. So 2 times 140 is 280. So 280 for 3. 3 times 140. 3 times 140 is 420. 420. Then 4. 4 times 140 would be 560. So in 4 hours we go 560 miles. So that's easy. And this equation part here, well, all we've been doing is multiplying the number of hours times the distance. So it's going to be 140t for our expression. Now we got to work backwards. Well, if we know what the number of miles is, right, we multiplied some number of hours to get that number of miles. So to work backwards, we just have to divide. Oh my goodness, 104.5 divided by 480, that's something crazy. Well, we could always write it as a fraction, 105 over 140. That'd be easy enough to do. Or we could test and see in the calculator, 105 divided by 140 is 0.75, so that's not a terrible decimal. Right? So we're just going to put 0.75. If you got some sort of awful repeating decimal, then you'd want to leave it as a fraction, but it's a nice decimal. So let's try 350. So working backwards, 350 divided by 140, 2.5, also a nice decimal, so that works. And let's see, 455. Oh, I got a bad feeling about this one. 455 divided by 140. Oh, that's times. 455 divided by 140. Oh, 3.25, so not bad. Okay. Oh, missed out on this 1/2 over here. So if it travels 140 miles in 1 hour, in half an hour, it'd travel half that distance, or 70. So let's go ahead and plot some of these on our grid. I put a grid together here. Notice I haven't labeled the side yet. Distance in miles. So we got our distance, and our graph is labeled. We know what we're measuring on this axis, and we know what units we're using. Down here, we're measuring time in hours. So we labeled what is being measured on that axis and what are the units. So let's go ahead and plot some points. So we had 1 and 140. And notice I wanted to make sure that I could cover my whole span here. So it goes up to like 560. That's actually, oops, that's going to take me all the way up here. Oop, there's 560 all the way to the top. So I wanted to get up to about 500. So I decided to go up by 20s. I could have gone up by like 25 or something like that. I don't think 10s would have fit on the grid. So I was trying to make the graph as tall as possible. And the reason for that is if I have to graph something like 455 and I'm going up by 25s, I'll hit 450 and then I'll have to, where's 455? It's just a smidge past. It's easier to, it's easier if I'm going up by 20s. It's just a little bit better. I mean, it'd be better if I was going up by 10s or even by 5s, but then again, I don't have that much paper for it, so. Okay, so we've got 1 hour and 120, 40 miles. We had 2 hours and 280, so here's 2 and 280. 3 and 420, so 3 and 420. And 4 and 560, that's an hour. This would be half an hour. I'll mark the half hour marks. All right. So this is half an hour, and here would be 70 miles right there. So it's 0.5, comma 70. 20, 40, 60, 80 is up here, so we're halfway between 60 and 80. Next we have 0.75 and 105. So let's see, there's 0.75 and 20, 40, 60, 80, 100. We're actually just a little past 100. So that is 0.75, 105. I got 2.5 and 350. So here's 2, 2.5, and 100, 200, 300, 50 right here. 2.5, 350. Let's see, we have 3.25 and 455. So let's see, here's 3, there's half. 3.25 is 3 1/4, so there's 3 1/4. And notice, by the way, that's supposed to be 455. So there's 400. Oh, there's 400, 20, 40, 55. That makes sense. So it's 3.25, 4, 55. Notice when I saw that my hours were 0.75, 0.2, and 3.25, those are all quarter hour type marks. And so, hello. A couple quick things about this before we go. One is this particular type of relationship between time and distance is called a direct variation. And we say that time and distance vary directly. And what that means is that to get distance from time, all I have to do is just multiply by some constant. In this case, it was 140. So I multiply time by 140 to get distance. Or to go backwards, I divide distance by 140 to get time. There's no, like if this is a y equals mx plus b sort of thing, if you look at our line, it doesn't have it has a b, but the b is 0. Right? So direct variation will always have the point 0, 0 in it. That's your y-intercept. And again, to find, say, for distance times a common direct variation sort of relationship, to multiply, to get distance from time, all we have to do is multiply. That's it. We're multiplying by, of course, the same number every time. And to go backwards, we divide by the same number every time. There's no adding or subtracting anything tossed in there. Second of all, when you're setting up your grid, remember you want to have what is being measured on each axis and in what units. And then finally, and once you plot out your, well, not finally, hold up, Len. You want to make sure that you're labeling your axes